Welcome, this is Mathematics in the Modern World. Objectives. In this presentation, I will able to disseminate my learnings in this subject regarding of these topics. Number and pattern, mathematics as a language, and logic. Pattern. What is pattern? Pattern is any regular repeated arrangement, especially a design made from repeated line shapes or colors. So we have here some example. 1, 3, 5, blank, 9, blank, 13. So, the elements of the patterns, ang bawat number dito is what we call the term. So, mapapansin natin na ang bawat term ay nag-a-add lang naman ng number 2. 1 plus 2 is equals 3. 3 plus 5 is equals 7. So, ang answer natin dito is number 7. 7 plus 2 is 9. 9 plus 2 is 11. Ang answer natin dito is 11. 11 plus 2 is 13. 4 probable patterns. Number 1, single repeating pattern. Number 2, Fibonacci sequence. Number 3, 2 alternating patterns. And number 4, letter sequence. What is single pattern? Single repeating pattern. So, I have here, sa single repeating pattern, pwede nating gamitan ng addition, subtraction, multiplication, and division. Here's a number 1 example is addition. So, mapapansin natin na bawat term ay nag-a-add lamang ng number 4. 2 plus 4 is equals 6. 6 plus 4 is equals 10. 10 plus 4 is equals 14. And 14 plus 4 is equals 18. So, our answer here is number 18. And the next example is 18, 15, and 12. So, mapapansin natin na mula sa mataas na number hanggang sa mababa na number. So, ang gagamitin natin dito is subtraction. 8. So, mapapansin natin na bawat term ay nagsasubtract lamang ng number 3. 18 minus 3 is equals to 15. 15 minus 3 is equals to 12. And 12 minus 3 is equals to 9. So, ang answer natin dito is 9. Sa number 3 naman, we have here, ginamitan ko dito ng multiplication. So, maghahanap tayo ng number na i-multiply. So, mapapansin natin na bawat term ay multiply sa 2. For example, 4 times 2 is equals 8. 8 times 2 is equals to 16. And 16 times 2 is equals to 32. So, number 4 naman, dito sa example na ito ay division. So, mapapansin natin na bawat term ay nagdi-divide lamang sa 2. 18 divided by 2 is 40. 40 divided by 2 is 20. And 20 divided by 2 is number 10. So, hindi natin dito nalagay. Our answer here is 32. Next is Fibonacci sequence. We have here the so, ang Fibonacci sequence ay ina-add lamang ang first term sa second term para makabuo ng third term. So, we have 2 plus 3 is equals to 5. So, number 5 dito. Mali lang. 2 plus 3 is equals to 5. 3 plus 5 is equals to 18. And 5 plus 8 is equals to 13. The missing term here is number 13. So, next is 2 alternating patterns. So, magdodraw lang. So, sa 2 alternating patterns ay merong dalawang pattern na nag-a-alternate. So, magdodraw tayo dito. Like this. So, sa first pattern, nag-a-add lamang tayo, which is 4, 8, and blank. So, mapapansin natin na nag-a-add lang dito ng 4. 4 plus 4 is equals to 8. 8 plus 4 is equals to 8 plus 4 is equals to 12. So, sa next pattern is 6 and 12. So, mapapansin dito na nag-a-add lamang ng 6. 6 plus 6 equals to 12. 12 plus 6 is equals to 18. So, our answer here is 12 and 18. Next is letter sequence. So, we have here the B, D, G, and K. So, para mapadali nating masagutan, tatandaan lang natin dito ang number, which is letter B, letter D, letter J, letter K. So, mapapansin natin na may mga agwat siya. Sa first is 1, next is 2, next is 3 letters. So, sa ating next term, maybe we have 4 letters. 1, 2, 3, 4. So, our answer here is letter P. So, next, set. What is set? Set is a collection or group of well-defined objects. These objects are called elements or member of a set. It is definitely common for us to use the concept of sequence in everyday experience. How about in mathematics? A set of whole numbers, a set of points, a set of integers, and a set of solutions for an equation. What is well-defined set in mathematics? In mathematics, a well-defined set clearly indicates what is a member of the set and what is not. How to describe a set? So, we have here some symbols, capital letter and a lowercase letter. We use capital letters to represent the set and lowercase letters to represent an element in the set. So, we have here some symbols. This one na parang letter E. So, it symbolizes the element of the set. So, we have here naman na E din na parang na-crush out, what we called not element of the set. There is fairly simple notation for sets. We simply list each element or member separated by a comma and then put some curly brackets around the whole thing. So, mapapansin natin dito na this one are brackets, those one are brackets. The numbers here are what we called elements, and this 3 dot is what we called ellipsis or continue on. Finite or infinite set. So, sa finite set, the terms are countable. So, mabibilang natin. In infinite set, the sets are uncountable or hindi mabibilang or hindi natin alam kung kailan matatapos. Equal set versus equivalent set. Two sets that contain exactly the same elements are said to be equal sets. If we are given here some examples, set A is A, E, I, O, U, and B, set B is E, O, U, A, E. So, masasabi natin siyang equal set because every elements are the same and the number of elements are the same. Next is two sets contain exactly the same number of elements are called equivalent set. If we have here some example, letter A, set A 1, 2, 3, 4, letter B, set B, B, A, L, L, and then the sets here, the number of elements here are the same. So, kahit ano pang mga elements, if magkapareho naman ang number of elements, that's what we called equivalent set. Basic operation on sets. We have union, intersection, complement of set, and difference of set. In union of sets, the union of two sets is a set containing all elements that are in A and B. So we have here's some example. Letter A is 1, 3, 5, 7. Letter B is 2, 4, 6. Then A union B is 1, 2, 3, 4, 5, 6. So ikakopy lang natin ang lahat ng elements sa A at B. If meron dito tayong magkapareho, so hindi na natin dodoblehin sa pagsusulat dito. So next is intersection of sets. The intersection of two sets A and B denoted by A, this symbol, this symbol A intersection of B consists of all elements that are both in A and B. So mapapansin natin dito, in A we have A, B, C, E, and F, and set B, D, E, F, G. So titingnan lang natin or hahanapin natin ang magkapareha. So ang magkapareha dito is letter E and F. So that is why our A intersection of B is equals to E and F. So we have naman the complement of set. The complement of set A denoted by A and the symbol of C read as A complement or A prime is the set of elements that are in the universal set not or not in a set A. So we have a universal sets C, D, E, F, G, H, and I, and set A is C, E, F, G. So mahanap natin ang A complement, ang nasa set A is ika-crash out lang natin or ima-minus natin ang mga ika-crash out natin ang mga elements. So we have your C, E, F, and G. So ang natira lamang is D, H, I. So ito ang answer natin. As A complement. So we have here the answer. Then A complement is equals to D, H, and I. We have naman difference of sets. The difference of set subtraction is defined as follow. The set A to B, A minus B or AB consists of elements that are in A but not in B. So dito, importante kung anong nauna. Since ang nauna is A sa B, we have here some example. If set A is equals to 2, 3, 5, and then the B is 2, 4, 6. So, isa-subtract lang natin yung 2 dito sa B. And that is, cash out lang natin, 2, 4, 6. So, mali po ang answer ko dito. So, A, B is equals to 3 and 5. So, ang A difference of B is equals to 3 and 5. So, that is why our answer here is 3 and 5. So, next. Solving problems using diagram. Among 50 students in a classroom, 20 chose math as their favorite subject and 3 chose English and 10 both math and English. Find the number of students who take math but not English. Letter B, do not take English, and letter C, take exactly one of the two subjects. So we have 50 students, 20 choose math, their favorite subject, 30 choose English, and 10 both math and English. So, unahin lang natin ang nahuling statement. So, we have 10. Ilalagay natin dito. This circle is for English, and this circle is for math. So, we have 10 students chose both math and English. So, ilalagay lang natin dito ang number 10. So, 20 chose math. So, isa-subtract lamang natin yung 10 sa 20. That is why the answer here is 10. And the 30 chose English. Isa-subtract lang din natin yung 10 sa gitna. So, 20. So, let's answer this question. Take math but not English. So, ang kumuha daw ng math pero hindi kumuha ng English. So, ang answer lang natin dito is number 10. This one. Answer here is number 10. do not take English. So, we have here 50 students but hindi kumuha ng English. So, 50 minus 30 is equals to 20. So, ganun lamang po kasimple. So, number C, take exactly one of the best the two subjects. So, at least one lang daw po yung kinuha nila. So, hindi na natin to bibilangan kasi kumuha sila ng both math and English. So, ito na lang. 20 and 30. So, 20 and 10. So, ang answer natin dito is 30. Next, a real number. In real number, we have some properties. The first is closure property. Let A, B, and C are elements of a real number. The sum of product of the two real numbers is a real number. For example, closure property of addition A plus B is equals to a real number, is an element of a real number. In closure property of multiplication, A times B is an element of a real number. So, in commutative property, let X, Y, and Z are elements of a real number. In addition, the order of addends in addition does not matter. For example, X plus Y, Y plus X is equals to Y plus X. Kahit balik ta rin ba natin, so magkapareha lamang. So, in multiplication, pareha din sa addition, the order of factors in multiplication does not matter. So, X plus times Y is equals to Y times X. So, we have some properties. So, associative property, identity property, inverse property, and distributive property. Next is elementary logic, connectives, quantifiers, and negation. What is connective in mathematics? A function or the symbol of representing a function which corresponds to English conjunctions such as and, or, not, and, etc. that takes one or more truth values as input and returns in single truth values as output. So we have connectives are used to create a compound sentence. We have here two simple statement. Number one statement is we will eat at Jollibee and then we will eat at McDonald's. So to create a compound sentence, we have connectives, and our connective here is or. So the compound sentence is we will eat at Jollibee or we will eat at McDonald's. So we have here some connective, the symbol and the type of statement. If our connective is and, the symbol here is this one. And the type of statement is conjunction. And if our connective is or, we use this symbol and the type of statement is this conjunction. And if our connective is if, then our symbol here is this one and the type of statement is conditional. And if our connective is if and only if, we use this symbol and the type of statement is biconditional. Quantifiers and negations. Examples of quantifiers are no, some, all, and etc. Negation, the negation is the opposite of the statement. So we have a quantified statement and its negations. No y or z, and the negation is some y or z. Some quantified statement, some y or z, the negation is no y or z. And some y are not z, the negation is all y or z. All y or z, the negation is some y or the negation of all y or z is some y are not z. Proposition and mere sentence. Proposition, a declarative sentence or statement which is either true or false is called proposition. So what is declarative sentence? Declarative sentence is simple statements that relay information. written in the present tense and expresses a direct statement. And with a period, it state a complete thought, and last consists of subject and predicate. So we have here some example of proposition and mere sentence. The number one example of proposition sentence is I clean the house. So masasabi natin siyang proposition sentence dahil it ends with a period, it indicates subject and predicate, and it's subject and predicate, and it is a complete thought. So, number 2 is 4 plus 6 is equals to 10. So, masasabi natin siyang proposition sentence since 4 plus 6 is equals to 10. So, it is a complete thought. So, in mere sentence, we have an example. How is your day? So, hindi siya proposition, kundi mere sentence siya because in proposition, we have declarative sentence. So, this example here is not a declarative sentence, but it is a interrogative sentence. So, nag-a-ask siya. So, hindi siya nagtatapos sa period at hindi siya complete thought. So, number 2 example is 36 minus 18 is equals to x. So, mere sentence siya kasi hindi siya complete thought because napapaisip pa tayo kung ano ba ang symbol ng x. Conditional and related statements. Given a conditional statement, we can create related sentence, namely converse, inverse, and contrapositive. They are related sentence because they are all based on the original conditional statement. The converse of conditional statement. We can write the converse statement by interchanging or swapping the rules of hypothesis and conclusions of the original conditional statement. So, P as our hypothesis and Q is our conclusions. So, converse of conditional statement is change lang natin or sinaswap lamang ang hypothesis and conclusion. So, we have P implies Q. The converse of this is Q implies P. So, the inverse of conditional statement. The inverse statement is created by negating both the hypothesis and conclusions. So, in this case, hindi na natin siya isa-swap or i-change. So, ina-negate lang natin yung hypothesis and conclusions. So, we have here P implies Q. And the inverse of this is not P, it implies not Q. So we have here the contrapositive on conditional statement. The contrapositive of a conditional statement of the form if P then Q is F, not Q then P. Symbolically, the contrapositive of PQ is not Q, not Q, not P. A conditional statement is logically equivalent of its contrapositive. So, dito, i-negate natin at chine-change din or sinaswap ang role of hypothesis and conclusion. So, we have here the table. So, this one is the converse, this one is inverse, and this one is contrapositive. Truth table and tautologies. Truth table. A truth table shows how the truth or falsity of a compound statement depends on the truth or falsity of the simple statements from which it's constructed. So we have here some table. If our letter is only one, gagamit. So, maglalagay lang tayo ng dalawang row. If our letter or our hypothesis and conclusion is only 2, lalagay lang tayo ng 4 rows. And then, if 3 naman, lalagay tayo ng 8. So, negation or not, opposite root values from the statement. So, ito nga, negation, ine-negate lang natin yung hypothesis or yung conclusion. So, number 2, conjunction, and only true when both statements are true. See, we have here P and Q. So, ang ang magiging answer is true if our hypothesis and conclusion is true. True and true is true. This conjunction or only false when both statements are false. So we have here P and Q. If the hypothesis and conclusion is the same false, our answer is false. So P or Q is false. So the conditional and logical implication are P implies Q, also known as if then results, true in all cases if the case of T implies false. So dito, if nauuna yung T sa F, our answer here is F. And the rest of this are true. So logically, by conditional, only if true, if both statements are true or false, the result is true. So if the statement is parehong true, our answer is true. And if our sentence na naman is parehong false, our answer naman is true. So, babalik tayo. Sa conjunction, true and true is true. Sa disconjunction, false and false is false. Sa conditional na naman, true and false is equals to false. And logically, true and true is true, and false is true. So we have tautologies, contradictions, and contingencies. A compound proposition that is always true no matter what the truth values of the position that occur in it, it is called tautology. A proposition that is always false is called contradiction. The truth table for a tautology has T in every row, then truth table for contradiction has F in every row. A proposition that is neither tautology nor a contradiction is called contingency. Contingencies have both T's and F's in their truth tables. Logical equivalence. Two propositions are materially equivalent if they have the same values. It also means that they materially imply to each other. If the biconditional that expresses their material equivalence is a tautology, then the two propositions are said to be logically equivalent. So we have a symbol P is logically equivalent to Q. So the symbol is P, logically equivalent equals T. So, gagamitin natin itong symbol na to. So, that could be all. Thank you.